Hello everyone, this is Suresh Kumar, working as Assistant Professor, Institute of Aeronautical Engineering, Dundigal, Hyderabad. So today we discussed about the reservoir planning. In the previous lecture, we discussed about the what is meant by reservoir and the types of reservoir, and also the gates which is provided for the reservoir and the purpose of the reservoirs can be discussed in the previous lectures. Now we have to be discussed about regarding the reservoir planning, how to plan the reservoir. So let us see that one, the reservoir planning for the best effect of the design of the irrigation projects of the investigation and must be carried out in the three stages. The first one is recognized survey, and the second one is primary survey, and third one is detailed survey or construction of the survey. So in these three types of the investigations will be done while planning of the reservoir. So let us see the one by one how to plan the reservoir. So reconnaissance survey. So reconnaissance survey is the survey that find out the number of project sites of where the storage of the water can be done, and the survey of the inspection of the region is done, data collected physically and without using the prescribed survey instruments. So primarily you have to take whether it is the possibility of the construction of the reservoir and how it can be useful. And why? Because we are using to spend crores, thousands of crores of rupees when we for this project. That's why we have to be primarily whether it is possibility and feasibility can be investigated the primarily. So recurrence survey is the following information to be collected. What are the information to be collected? The first one is catchment area. So this is a primary, how much the catchment area on particular of the construction of the reservoir area. So next, vegetation. The possibility of the vegetation means the greenery system, how much it can be, surroundings can be affected. Next of the catchment area. Next, soil type. How we are going to be estimating the catchment area? Why? Because the greenery vegetation is catchment area means whether without the catchment area is large, but the rainfall capacity is very less, and the runoff will be also be very less. It is useless to be construction of the reservoir project. That's why we should have to be plan and types of the some primary we have to be take the reports. Next, the vegetation is the catchment area of the soil type. Next, primarily soil type. Which soil it is, whether the soil is A type, B type, C type, D type classification is there in the previous for calculation of runoff. So different soils and different can be, each soil contains one curve number. So this can be calculated by the by using SCSCN curve number of the calculation of the runoff. Based on the curve number, how the infiltration capacity, the storage capacity, and can be some things can be known by using the soil investigation and the soil types. Next, slopes. In these slopes, the catchment area, the runoff will be forms by using the streams. How it can be soil slopes can be provided. The slope is more, what happens? The runoff will be the less. The slope is maximum, so runoff will be the less. Why? Because the water will be fast, can be flow in the ground. It cannot infiltrate and it can be went to this outside as the rivers. So that's why we have to be find out the first slopes. Very deep slopes can be it cannot be considerable for the calculation of the estimation of the reservoir. Next, existing ponds. Is there any existing ponds and the surroundings can be investigated for the recognized survey. Next one is preliminary survey. In the preliminary survey, in the previously this can be eye observation. Means in the previously recognized survey, what is the primarily have to be observed from this one. Without using the instruments, we have to be just take the point source can be noted. So next, preliminary survey. In the preliminary survey, nothing but this survey is carried out by exploiting supervision with a modern instrument, and it can be take few months of the takes for the investigation. All aspects can be take. However, depends upon size of the project and carried out for the dry season with careful of the planning. Next, preliminary survey divided into two parts. What is the engineering survey, hydrological survey, and geological survey? So this is the, in the previous one, this one is the difference between this. This is a detailed estimation for the possibility of the construction of the reservoir. So this is the engineering survey, hydrological survey, and geological survey. Next, engineering survey. What is meant by engineering survey? What we have to be find out for the engineering survey? In this type of survey, various type of the surveys can be carried out, such a plan and table and transfer survey and aerial photographic survey, and also aim to survey the prepare the control the maps of the city. Of course, we have to use in a lot of remote sensing and GIS. The vast software can be used for the pin to pin point. They will be estimated what is the area can be to the satellite. It may be estimated the total area and the possibilities and the vegetation, and not only that, the whole information can be gathered through the remote using the softwares. So it can be forms of the slope maps, dem maps, preparing of the and also aspects map, and also some of the slope maps can be also prepared, and the contour maps, very very important. Contouring the maps can be prepared by using the slopes. Can be what have you discussed, slopes, how much the slopes will be from this catchment area, what it may be, the slopes can be varying, can be known for the from this the. So that is the main important, the contouring the map. So the contour map gives the following information. What information can be gives? Water spread, how much area it can be water spread, and the capacity of the reservoir, and also the capacity is suitable of the dam, and the site for the waste wear of the outlets. These are some of the information can be known about the surveys of the contouring of the contouring can be provided, different type of the contours of the different levels, and 20, 30, 40 like that. So based on this one, we have to be zero. You have to provide and take the information from the by using the software. In the previous olden days, they are going to be prepared manually. Now the advanced technology and the vast, we have to find the remote sensing and GIS is the can be used for the most of the survey for surveying. So it can be very accurate, can be measured from this type of the estimation. The next one is the hydrological survey. So what is meant by hydrological survey? We know very well. Hydrological survey means it can be possibility of the rainfall and the availability of the water can be studied through the hydrological survey. So whenever the storage is constructed, it will be essential to extend the required amount of the water can be available in the site storage. Therefore, hydrological survey is the catchment area. Basically, this catchment area is done to collect the data for determining the availability of the water of the reservoir. So this is a very very important, and we study the what I told runoff. By calculate SCSEN method, TR55 method. So there are a lot of methods is there to calculate in the soil conservation service curve number method. So this accurate method which is have to be calculating the runoff estimation. So based on the runoff, you have to be very very important to whenever you have to be construct the hydrological structures. So now to study the runoff and the estimated yield to determine the maximum discharge, to determine the how the it can be maximum discharge can be availability. Next, determination of the hydrographs of the worst flood to determine the spillway capacity and its capacity. So hydrograph is the worst flood to determine the spillway capacity and its capacity. So how to hydrograph? From the rainfall and runoff, we have to prepare the hydrograph to analyzing the water flow of the on particular catchment area. To separation of the base flow, the hydrograph is the very important by using the runoff estimation, and also the U to hydrograph, types of hydrograph and S type curve. These are some of the hydrographs can be used for the calculation and availability of the runoff will be known. So next one is geological or exploratory survey. So what is meant by geological survey? Geological survey is nothing but is a survey which is the structure, site structure maybe means it can be any valleys or hills and the slopes and the soil conditions, the capacity with it is a possibility to construct the reservoir on particular area. So all these categories will be known by investigating the geological survey. So let us see the first one is surveying the inspection and survey of the mapping. So the first the inspection of the mapping, which is the how much area it can be possibility storage and also the particular area for the construction of the reservoirs. Next, subsurface exploration. Subsurface exploration means runoff and subsurface exploration, the soil inside the infiltration capacity. So the soil content is very important. So infiltration capacity is the most important to investigate what the capacity of the reservoir. Next, subsurface exploration. Subsurface exploration is the subsurface exploration is nothing but to water tightness of the basin. So on particular area, how the water can be, you have to store the water. The water tightness is very important. So it can be any of the loose of the inside the voids can be, it can be structure will be the damages and huge damage will be constructed as well as environmental as well as most of the people will be died due to the uneven estimation and irregularity and careless of the estimation is the very dangerous. So that's why we have to water tightness means on particular area can be without porous soil. It may be rocky area is the best suited for the construction of the reservoir. Next, faulty structures in the basin. So the fault structures is the constructed in the basin. Next point, type and depth of the overburden. So overburden, what are the type can be overburden? The depth will be also be considered on particular area of the reservoir capacity. Next, groundwater conditions of the region. Very important. The groundwater is a how much depth of the groundwater can be available and how maybe why because how the groundwater condition, it may be the availability of the water is not there in this bottom. What happens, the infiltration capacity will be also the increases, but there is a water layer in between the some extent, but maybe the infiltration capacity will be the less and the storage will be the increases on the few months. That is a very important. The very needed to the subsurface water layer has been found. So based on this one, the depth of the groundwater conditions. So to avoid the infiltration capacity, if infiltration increases, infiltration more, what happens? The storage capacity will be the decreases slowly. So that's why you have to use the storage capacity of the infiltration capacity. So that is the groundwater types of depth of the overburden, groundwater conditions and their regions. So that is the one of the point of the geological survey. Next, locality of quarry sites, the construction material. Very important. Why? Because I am saying that very important. So the locally available material due to the construction of the large dams or hydrological any of the structures, locally available materials. Why? Because it can be lot of affected in the construction of the reservoirs. So why? How it can be affected? It can be affected by affected. So the materials which is acquired from the long distance, what happens? The lead charges will be the more, and more labor will be required. Why? Because the construction of the sites will very narrow. Sometimes maybe not possible to go the vehicles of that place also. So on that situation, what we want, the locally available materials, and local means the availability of material within the 2 to 3 kilometers or maximum 5 kilometers range. The availability of the material is the very important for the construction. The cost will be a lot of affected. The cost may be increase, may be decrease. So the cost is increases the availability of material can be acquired from the long distance. What happens? Automatically the construction of the cost, the estimation will be the more can be increases. That's why very as the civil engineer, we are going to be design any of the hydrological structure, any of the structure, the locally availability of the material, you have to be give the first priority for the construction of the materials. Next, detailed survey. So preliminary survey, recovery survey, and engineering survey, and geo survey. Next, detailed survey. What the detailed survey? In the details of the survey, after the preliminary survey, only few sites of the selected for further consideration. So this type of the survey, what happened? The official sites estimated of the each of the selected site should be prepared. So first of all, you have to select some or two sites. The availability of the feasibility can be, all aspects will be considered, and it can be okay. It can be selected of the site, can be preparation and give the sanction for the construction of the hydraulic structure like the reservoir construction. So next, detailed designer of the various storage structures are to be prepared for drawing officially the cost working out. So the relative merits and demerits of the two or more sites can be taken of the consideration. Adopt one site final. So everybody should have to do like that. The estimation will be taken at 2 to 3 places. Very important. The feasible, the foundation area, especially the foundation area, is very load bearing capacity of the soil in the geological survey. The foundation, for the better foundation, the soil condition on particular area, and also as I told, the water tightness. So these are all the very important factors for any of the. So maximum all are will not be satisfied, but we will be considered among the 1, 2, 3 places. So we can decide it any one place for the consideration as adapted. Next, points to be considered: the site selection of the reservoir. What are the finds? That to tribute the high content should be avoided, and the size should be such that optimum storage capacity is available. For desired optimum storage, the maximum storage capacity will be used for the construction of the reservoir, and the size should be easily accessible for the road and railway. So as I told, locally available materials, and also the site will be, if possible, all area we are not to be not same. So that's why the maximum possibility of the access of the road and railway construction. And next one, the construction of the materials should be available on the necessary on particular area. So as I told, the materials can be availability and feasibility of materials. Can you avoid the labor charge, and lead charges will also be reduced. It can be affected in the cost. Next, data should be collected for the irrigation project. What are the data should be collected for the irrigation? The first one is the detailed investigation consists of soil survey and the field work availability of the water, and the gauge of the river, and fixing of the dam, availability of the materials of the construction, sedimentation problem, the contour survey of the reservoir basin, and types of the dams, alignment of the main canals. So that is the some of the criteria to be constructed while data irrigation projects. So what are they? Let us see one by one. Soil survey. So as I told, soil survey, they're very important. As I told, in the geologically, the soil investigation will be considered. What is the capacity of the soil? The infiltration capacity is how much? Which type of the soil? The black part in soil will not be avoid to construction of the huge reservoir of the structures. And next, so the soil is condition is very important for the reservoir planning. And the second one is field work availability of the water. For doing all this project, the availability of the water for construction of the one particular structure, where it have to be availability can be seen. And also the gauging of the rivers, how the gauge of the rivers can be diverted, and the fixing of the dam site. So dam site can be fixed on particular area is especially on that particular area have to be fixed on that one. And sedimentation problem. So sedimentation problem is the problem. So why the sedimentation? The silt particles will be can be available in this. It can be stored. Avoid the silt in the on particular area. It can also weak and the structures. Thus we have to sedimentation problems can be avoided. And next one is contour survey of the reservoir basin. As I told, the why you have to do contouring. Contouring is the we have to be on particular area how the slope of the catchment area to water can be runoff can be flowing on area and due to, through the streams. So that's why there is a very how much area it can be deep steep, how much area it can be light slope, and all of this can be known for this one. So next types of the dams. So which type of the dam have to be constructed? It may be mixed or it may be purely RCC or earthen dam, or also we have to be consider while the all above the investigations data collection. Next, alignment of the main canals. For the construction of the reservoir, the alignment of the canal, how much slope is there, where you have to be divert the water whenever you have to use. After using of the open the gate opens the canal positions and the sloping area, how much area can be cultivated. All these points can be consideration for the irrigation projects, for construction of the irrigation projects. Yes, some methods of reducing of the silt theory. What are they? Selection proper dams such as, so selection of the proper dams of the site and should be catchment area with the less eroded portion, and construction dam in the stages, and providing the vegetation screens, and also proper reservoir design causing of the silt water to the escape, and dredging of the silts. So the why you have to methods of the reducing of silt. In the silt, very important problem. If the silt is deposit here, let us see that one in the reservoir construction of the dam. So silt is deposited here. What happens? It can be the storage capacity of the it can be reduced. First of all, the first affected the storage capacity, and also it can weak the structure. Also weak the dams. So it can be also affected in the fisheries. So and also the storage of the dead storage area, the silt can be formed. What happens? It can be removed. The capacity of the automatically be decreased. So that's why you have to be avoid the silt provision. Next, degrading of the silt. So this silt, how the possibility the silt can be avoided and it can be removed. Next, factors affecting on the silting area. So what are the factors affecting on silting area? So first one is catchment area. So based on this area by selection of the reservoir, the case of the fan shaped is the method. Deposit on the soil fractions will be more compared to the firm shaped catchment. These are the some of the catchment about the fan shaped and finer soil fraction will be more and finger soil fractions, and compared to the firm shaped catchment. These are the some of the shapes we have to be in the area of the catchment. These are the streams. Of course, streams can be provided here. So next, slope of the country. The slopes are steep. More particles are deposited through the slope. Why? Because that's why before we discussed about the slopes while preparation of the contouring, contouring of the slab. Deep slopes will not be not considerable. So the slope will be very narrow and moderate. So that's why you have to be take the depends upon the slope. Next, climatic conditions. Very, very important climatic condition. The climatic condition also affected the production of the silting, like dryness, rain, heat helps to produce the silting. So that is the some affected of the climatic conditions like dryness and the hot areas. It can be not preferable for the. It is not taken in the consideration. Next, nature of the soil surface. The soil can be loose. Silting is more along with the runoff. Along with runoff, the silt all comes and deposited in the reservoir area, or it can be affected, and also it can be by year. What happens? The capacity should be the automatically be reduced of the reservoir. Next, this is some zones of the levels of the reservoir. Let us TBL and top bund level, high flood level, and FTL level, full tank level, and live storage and dead storage and upper sluice. These are component parts of dead storage, live storage, and gross storage. This is some of the area component parts of the reservoir of the zones. So let us see the one point: control the level of the dam, top bund level, and the RL of the dam. Reduced RL means reduced level of the dam, which depends upon the capacity of the storage of the flood, like and free road. The height of the dam may be selection and difference between top bund level and ground level. That is the difference of high flood level, HFL. Let us see the HFL. See HFL, TBL and bottom is HFL. HFL is nothing but high flood level. It is the maximum, the RL up to the where the water can be rise in the reservoir. Water can be rise in the reservoir. Next, full tank level. Full tank level. Full tank level is the level the water in the reservoir is stored up to the level of known as full tank level or full reservoir level. We call it as another point, which is full reservoir level. Usually the crest of the spillway is kept in this level. So FTL letter. It is the full tank level. What we discussed now. So next, lowest water level, LWL. Lowest water, the minimum capacity of this water can be stored. So that is called we can also call it as dead storage. It is also lowest RL of the water level of the reservoir. It goes to below the low water level. Then the water can not be drawn in the reservoir. So next, dead storage, live storage, gross storage, and the freeboard. What is meant by dead storage? These are the points will be very important and components for the estimation of the reservoir. So next, dead storage. What is meant dead storage? The storage below the lowest till the cannot be used, hence called dead storage. Let us see in the diagram. You can understand. This is the dead storage. This is the under the lowest sluice. We have to be what are the area we consider it as the dead storage. Next, live storage. Live storage is nothing but the low LWL and FTL. So called live storage. Live storage is also live storage equal to irrigation requirement plus tank losses. That is equal to live storage. This is the live storage. In between the storage level to full tank level. We called it as live storage. Next, lowest water level. It is the lowest level RL of the surface in the reservoir. The water goes below the lowest water level. The water cannot be drawn out in the reservoir. Cannot be drawn out in the reservoir. That's why we call it as the reservoir. If the water goes below level, The water cannot be drawn out of the reservoir. So this is the lowest water level. And the freeboard. What do you mean by freeboard? Freeboard is equal to gross storage. Sorry, gross storage is nothing but it is the storage of the FTL in the reservoir. Gross storage is equal to dead storage plus live storage. So let us see in the diagram. Gross storage is here. See that one gross storage. It is the dead storage plus live storage. So we can we call it as the gross storage. Next, freeboard. Freeboard is the vertical distance between the tank bund level and the high flood level. A clear margin is kept for measuring of the safety and should not be crossed of the dam. So this is the some important definitions while the reservoir, construction of the reservoir, and also the component parts of the dam. So we have to also call it as. Next, reservoir capacity, very important. In this, we have to flood hydrograph of the flow, and it is flood hydrograph flow in the several years of the you have to be collected. Second one is mass inflow of the curve. The plot between the inflow of the reservoir with on particular time and demand curve. It is the plot between the accumulated demand with the time. Based on these 3 points, so we have to be estimated the reservoir capacity. Next, flood hydrograph. See here, see that one flood hydrograph flow. Let us see the flood hydrograph from the storage, the dead storage in the QMX will be in the y-axis, and the number of years you have to take it as consideration in the x-axis. So based on this one, what we required in the particular year to on particular year, we have to be take the shading portion, how the value of the water can be inflow on particular some years. It may up and downs, maybe the maximum flood level we have to be taken into consideration, and this data can be helpful especially for the construction of the storage capacity of the reservoir. Next, mass inflow curve. Let us see the curve is there. 1957 to 58, 15 like that is time number of years, and it can be drawn the up and downs. The water level can be take it different years. It may be changes. It may be changes and may be varies due to how it may be varies due to depends upon the runoff. The availability of the catchment of the rainfall is also influenced. Let us see that one. This is also one of the accumulated and variable rate of the demand. Accumulated demand and variable demand time as per the demand in hectares and meters accumulated, and accumulated demand is also given. As per that one, you have to be demand variation of the rate of the demand. In particular area, it may be changes of the demand. In this, what is the difference? Accumulated means we have to take the straight line will be taken as the increasing will be the commonly you have to take. But here what happens? In this one, the particular break-even point like that, you have to take the point and take the consideration from this consideration of variation of the demand will be changes. That is the accumulation of the demand. So this is the estimation of the reservoir on particular area, how we have to be find out. So let us see that one. Let us see the graphical representation of 1980 to 1960, 61, 62 like that. So we have to write years, and also here is the mass inflow hectares, 100 hectares meters can be take it as y action, and first we have to be demand curve will be drawn like this, and how from this point, how the value will be changes from the up and downs. What is the up and down? The up and downs will be the area, the particular on particular year of that point, how the maximum floods will be comes under this runoff. So that's why you have to be check it as each of the one. How to draw this one? First we have to draw A2, A3, A4, A4. Draw the cross section and all tangential lines of the can be drawn on particular on particular points you have to be selected 1, 2, 3, 4 like that. So first of all you have to draw the tangential line and take it as the minimum or maximum value you have to be find out. So based on you have to draw one triangular triangular section, take it as maximum value you have to find out where the particular here is the small, the variation will be the small, here the moderate, and this is the maximum of the take. And particularly what happens, you have to draw first cross section and triangular, rectangular triangular will be drawn. So take it as here in the x-axis as usual. The slope can be taken based on the slope. How much is the slope? We have to be find out. Here is the 2100 is the maximum on particular year, on particular area. The floods will be the comes. That's why based on this data only determined you have to be capacity of the reservoir. So this is the very very important, and by using this type of these structures, let us see E1, D1, E1. So here is the values how it can be changes. So that is the particular point. So based on this all this one you have to be find out the reservoir capacity. So this is the calculation of reservoir capacity as given the 1960, 61, 63, and the discharge cubics will be find out. So here see that one, the maximum hectares, this is the x-axis is the, for suppose is 2100. The year on particular area, how much the year, it can be seen here. First of all, I think so 62 years and 3 months. Like that you have to take the length. And on particular point you have to take the maximum value of inflow can be calculated. Reservoir capacity will be the calculated on particular year. So this is the, so this is some given the problem 1963, 64 up to the the capacity will be increased as discharge in cumex will be calculated here, and the storage capacity required to some of the cumex, and this is the one of the problem has been solved in the graphical representation as given to understand the better. So let us see the some points will be taken here. The take it as year wise you have to take the find out, and here the accumulated cumex can be taken in the right side, and take the points here by this is the drawn the tangential lines. The tangential line, the maximum, the on particular area, it may be changes the value from one point to another point, and again it can be changes. So the maximum, let us see the perpendicular point can be, line can be drawn here, and join of these two. This is the triangular section portion which we have to be the area you have to know, and the height will be also considered by using the y-axis accumulation length, and you have to know x-axis value and y-axis value. So based on this you have to find out the slope. The slope value is the value can be find out. That is the maximum storage capacity of the discharge will be find out. So this is the life of the reservoir. You have to how to calculate life of reservoir. The useful terminates of the reduced 20% of design capacity. Reservoir sedimentation measured in terms and traffic efficiency will be reservoir capacity inflow is equal to N is equal to F into capacity of the reservoir by inflow, capacity by inflow. This is the graphical representation of the capacity of the inflow of the particular project, and calculation reservoir. So the some of the definition is there. So you have to find the knowing the divide into capacity into suitable intervals are 10 to 20. So the percentage will be known respect to capacity of the reservoir efficiency. For assumed percentage reduced capacity, find the average trap will be find out, and also the determine the sedimentation inflow rate taking of the water sample of the drying sediments, and volume of sedimentation flow, weight of the annual specific weight of sediment. Calculate the annual sedimentation tap is equal to volume of the sedimentation inflow into average trap efficiency. So this is the calculation of annual sediment of the trap.
Next, second one, calculate the number of years to fill the reservoir with sediment. So this is the interval of the reduction of the volume. Annual sedimentation is equal to ST. It can be repeat the process with the further reduction of the capacity of the reservoir. So based on these formulas, you have to find the volume of the reservoirs and also calculate the percentage of the reduction of the average step efficiency, and sedimentation of the inflow of these points can be known. So life of the reservoir is equal to, so finally life of the reservoir is equal to total number of years divided by number of years required to fill the each of the volume of the some particular intervals can be find out. So this is the final capacity of the reservoir. So today we have to discuss the reservoir capacity and also how to calculate the reservoir capacity and types, and will be discussed on so many things. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.